everyone. Welcome to the third part of the IIC-OSIC-TOOLS tutorial. In this part, we will use KLayout editor for drawing layout and performing DRC and LVS checks. By now, you should have learned how to draw schematics using Xschem, and now it's time to draw the layout. So first of all, let's go ahead and open the schematics. So here I have the schematics with 2 transistors and 4 pins, and I can see the dimensions of each transistor. So I'm going to minimize this first. And as I said, for drawing the layout, we're going to use KLayout. The easiest way to open KLayout is with just typing K-E. So -E means you enable the editing mode. So let's press enter. And here you can see the technology is already loaded. So we're going to go ahead, File, New Layout. And then here again, you select the right technology. The top cell name should be the same name as the schematics. So we're going to set int. And for database unit, let's go ahead and type in 5 nanometers. All right, we have the area to draw the schematics. Here you can see all the layers that you're able to draw any shape in. Whichever layer that you want to draw something, you only need to select on it and then select box or path or polygon, and whichever shape do you want. You can, with easily clicking and then clicking again, draw the shape. And then with escape, you can remove the cursor from drawing. Then with selecting and pressing delete, you can delete the shape. Let's go ahead and place some transistors and draw our layout. So here under the library, you can select and then select the P-cell library from our technology, and you can see all the available P-cells. We're gonna first place the NFET. For placing NFET, you only need to drag it and drop it over. Now you can see the NFET. I'm gonna just place it right here, and then with ESC you can, that's good. And then with double clicking on our drawing and moving forward to the P-cell parameter tab, you can enable and disable. First, let's go ahead and change the level so we can see under the hierarchy. So I'm going to double click again here, P-cell parameters, and then set the parameter that we want. So we don't need depend well, we don't need depend well ring, and we need bulk type. So, and then here I only need to type in width and length of the NFET that I have here. I'm going to go back to the schematics. So the width is 1 micrometer and the length is 280 nanometer. All right, all set. So I already have placed NFET, and now I need the pivot. Again, drag and drop, and I have the pivot over here. So I'm going to click to place it, and then use escape button to stop placing more. So I'm gonna double click on it, P-cell parameters, barcode enabled, the dimension of the pivot, so it's 2 micron, enabled for 2 micron, barcode is enabled, and contact position, let's just place it bottom. Then I'm gonna have easier time connecting the gates together. Okay, now we have both our transistors over here. And if I need to move any objects, I only need to press move and then press on the instance that I want to move. Then is it like this? Maybe I want to move it a little bit further up, right here. All right. And then with pressing F, I can have the full view of whatever I have placed so far. So, okay, Now let's go forward and do the interconnections. We only had 2 transistors, so we're done with placing more components. We only need to do the interconnections. So we're gonna connect the gates together, source and bulks together, and then the drains together as the output. So I'm gonna start with connecting the bulks and sources for both transistors. For this, I'm gonna use metal layer 1 and then select box right here. Yeah, like this. So here was the bulk. This is my source, and then this is gonna be the drain, and this is the gate. Same here, bulk, source, gate, and drain. So I'm gonna select the metal layer 1 again, and then get another box like this. Okay. With double clicking on the layer that you've selected, you can enable it or disable it. So basically, you can hide it or show it. So here I have my metal 1 layers, and now I need to connect the drains and then connect the gates. So here is my drains. So I'm gonna delete just like this. Alright. And then for connecting the gates, I'm gonna use a path. Like this. You can click here, and then you can draw the path to whichever direction that you want. So I'm gonna press shift. So I wanna draw only to be able to draw only horizontal or vertical. So just like this. And now the gates are connected. And maybe I want to move this a little bit to the left. Yeah, then as it is this. Alright, so I'm done with the connections. Source and bulk are connected. Source and bulk here as well connected. Gates are connected together, and also the drains are connected together. So now I need to name the pins. Here I go down. So my connections are all in metal 1 layer. I'm gonna go and find metal 1 label. Here. So I'm gonna double click on it so I can show it, and then press text. So let's check the name of our pins. So VI, VDD, VSS, and VO. So this is our drain. So this is VO. I'm gonna press it on it. Then VSS. Right here. VDD. Right here. And then our input. Okay. So let's just go ahead and save everything. I'm gonna name the file in, same as schematics. Okay. Now I have schematics with all the components and with all the interconnections. So I need to first perform DRC check and then go ahead with the LVS check. So I'm gonna press on here the PDK options, load PDK options. Again, KLayout DRC option. So I'm gonna select the variant option. So the variant of the technology that I'm using here, we're gonna use D. Top cell name here is int. So yeah, everything is in, and I'm gonna press on KLayout DRC. Alright, so if I open the terminal again, here you can see all the checks performed by the DRC. I'm going to go back, and here with the marker browser I can see if there is DRC errors. So here I see. Okay, so the width of the line that I've used for connecting the gates together is less than the minimum. Minimum should be 230 nanometers, and I've used only 100 nanometers. So also for measuring, I can use the ruler here. Again, I hold the shift so you can see 0.1 micrometer, so 100 nanometer. I only need to make this a little thicker. I double click on it and then here. Okay, F, save everything. Okay. All right. There are no more errors, so we have DRC clean. Now we need to do the LVS check. So for LVS check, we need the spice file from the schematics. For this, I'm gonna open Xscheme and then go ahead with the simulation tab. So here I'm gonna set netlist directory. So my file was in process designs and in folder. Okay, and then I'm gonna go to simulation again, LVS, and LVS netlist plus top level is a subcircuit. And then when I press netlist, I should be able to see it in my directory. So I'm gonna leave this open. Let's open another tab. Here, see the spice file right here. So I call layout LVS options. I need the variant option. We use variant D. And the top cell name. Substrate name is VSS. Then that's it. Yes. Save all. And perform LVS check. Okay. Looks like LVS matches. I'm gonna check everything. Okay, there is a slight problem here. That the pin names don't match. So at the schematic side, the pin name was VI, but here I put VIN. So I can easily edit it. Double click on it. Okay. Again, run KLayout LVS. Alright, it is clear. Then we're all done and our layout matches the schematics. Thanks for watching the video.